Hello everyone, hope you all are doing well. So today we will be doing the next topic of our geography series, and the theory we are going to discuss today is seafloor spreading theory. In the previous videos we have already discussed the continental drift theory and conventional current theory, and this will be a kind of extension of conventional current only. So if you have not watched the conventional current theory of yesterday, please go and watch first and then watch seafloor spreading. That will be more that will give you more conceptual clarity on this theory. So let's start. Before starting, I must let you know that if you have not make notes yet, please do make notes. Please do start making notes, because the notes you will make will help you immensely. You will be able to revise your notes again and again, and that will be helpful. So please do make your notes, and please start this from the first video and make notes, so that your entire geography syllabus of all the important topics is covered. So let's start. Seafloor spreading theory. So this theory was given by Harry Hess in 1961. Harry Hess in 1961. It helped solve following puzzles. It helped solve following puzzles. So what were the puzzles which it helped solve? Number one, then why is ocean very young than continents? Ocean very young than, this is young than continents. If you see the age of ocean is around 200 million years ago, whereas age of continents is around 2 billion years ago, that is 2000 million years ago. So it solved this puzzle. Secondly, why all along elongated mountain like feature in ocean crust? Always, why we see always elongated mountain like feature in ocean crust, that is mid-oceanic ridges. Why there is mid-oceanic ridges? That is MOR, that is mid-oceanic ridges. So this was the second puzzle which it helped solve. Now number three is along mid-oceanic ridges, along MOR, there is constant effusive volcanic eruption. Constant effusive, that is quite volcanic eruption. V, that is volcanic eruption. So why there is a constant effusive or constant wild volcanic eruption around mid-oceanic ridge? This was another puzzle which it helped solve. Next one is that age of ocean crust slash basaltic rocks increase as we move from ridges to trenches. As we move from ridges to trenches. Okay, so age of constant basaltic or crust, age of ocean crust or basaltic rocks keeps increasing as we move from ridges to trenches. Why? That is one factor. Next one is that rocks on either side of ridges rocks on either side of ridges as well as equidistant have same remarkable similarities in age, in magnetic, physical and chemical properties. So it tends to say that suppose this is mid-oceanic ridge, and if you move this side and if you move this side, suppose we have moved 1 kilometer to this side and we have moved 1 kilometer to this side. So after 1 kilometer moving both the sides, you will see that the rocks found here and the rocks found here are very similar in properties. So why this happens? Why with as equidistance movement we see similar rocks? So this was another puzzle. So these are the puzzles which this helped solved. This helped to solve. So there are basic postulates which can be arrived at by this theory. So what are the basic postulates of this theory? First one is that ridges are located on rising hot flumes of magma. Ridges are located on rising hot flumes of magma. When we have discussed the conventional current, we discussed that suppose this is earth, so this is rising hot plumes of magma, and then going down cold plumes of magma, that is sinking cold plumes of magma, and this is lateral belt. So this we have discussed in the conventional current. So please do watch it, then you will understand this. Okay. And trenches are always located on trenches located on top of sinking cold plumes of magma. Top of sinking cold plumes of magma. Okay, so this is the one reason. Now see what happens. Mechanism we should discuss. Take the next page. Let's discuss the mechanism. So here we see that the hot rising plumes of magma fractures oceanic crust, creating ridges and not mountains, as it is a basic magma. Okay. Suppose I will be giving way with the help of a diagram. Okay. So here there is hot rising plume of magma. This is hot rising plume. So what it does, suppose this is the earth crust. This is earth crust. So what it does, it fractures the oceanic crust. This is earth oceanic crust, oceanic, okay, as it is in ocean only. So it fractures the oceanic crust and it starts effusive, or you can say quite eruption. Okay, you can see eruption coming out of here of basic magma. This is basic magma, that is why it is quite. Okay, this is crust, good, and you can see the this is crust, and you can see that I am trying to make it 3D diagram. So it is crust, and you can see that the quite magma, that is quite basic magma, is coming out. And since the rising hot plumes of magma are a permanent feature, this ridge will continuously experience quite eruption. So these hot rising plumes or magma is a permanent feature. It is not like that for a season there is hot rising plumes and then it is not present or it is absent. So this is a permanent feature. Permanent feature. That is why you will see that always there is quite eruption or effusive eruption around ridges, and these ridges are only nothing but mesophonic ridges. These are ridges. This gap. Now with every eruption, new crust is created near the ridges and old crust is pushed towards the trenches. So here the new crusts are created and this new crust starts pushing the old crust towards the trenches, and here you will be trench. Suppose this is the continental crust. This is continental crust. And you see that as new crust is forming here, the old crust is being pushed. So older rocks are pushed towards trenches because basic magma spreads horizontally. Why they are pushed only trenches? Why don't they accumulate here? Because basic magma flows horizontally. Okay, the viscosity of basic magma is very low, and then they start pushing the older magma. Okay, and lateral plumes move ridges to trenches. And another factor is that why they keep pushing that here we have lateral plumes also, and these more lateral plumes are moving from ridges to trenches. This portion is here we have trenches. Similarly here we have trenches. So due to these two regions, due to basic magma and the presence of lateral plumes, they are always pushed towards the trenches. Since eruption event creates crust either side of ridge, there will always be similarity. When there is eruption this side, it will be also similar movement this side. So suppose after 1 kilometer, one rocks moves here. So there only around 1 kilometer there will be movement. The movement of the magma will be very similar. Okay, that is why you will find similar rocks on both sides of ridges. Okay, and ocean currents created near ridges and destroyed in trenches here. Ocean, hence ocean remains young. So what happens here? It is created in near ridges, and in the trenches where there is sinking cold plumes. It is sinking cold plumes. So what happens at trenches? This magma gets inside the earth, or you can say these rocks are subducted into the trenches. And that is why the ocean crust remains always younger than the earth crust, because in earth crust once the crust has made, that is made, there is very less changes. But in oceanic crust there is continuous changes due to the magma coming out of ridges, and the rocks going down to the trenches. The crust is being subsumed in the trenches. So this is the mechanism of sea floor spreading. So I hope with this diagram you are able to understand it, and if you are not, please do restart the video and again do watch. In 1-2 times you will be able to understand this. This is nothing some rocket science. It is an easy concept only, and with good concentration you can easily understand it. So this was about sea floor spreading theory, and in the next video we will be doing the plate tectonics theory. So that is all for today. If you like it, please press the like button. Please do share and please do subscribe. It takes a lot of hard work to make such videos for you regular basis, and if you like, if you share, if you subscribe, it motivates us to make more such videos for you regularly. So that is all for today. Have a nice day. Thank you.